Hey guys, in this video I'm going to use the SR-PCE to configure a second segment routing policy that avoids the nodes that are used by the first one. So what I mean by that? We have a policy from 33 to 35 that takes this path, and the second, and of course this has a total T metric of 2. The second policy will take this path even if it has a total T metric of 101, because I will only tell the SR-PCE that I want it to be disjoint from the other one. And I won't tell it go from 33 to 31 to 35, I'll just tell it these two policies, this one which is number 2 and this one which is number 1, should not pass through the same nodes. And even though this one has a much higher cost, it will take this cost just to not pass through the same node. And let's actually do it. This is done on the SR-PCE. Let's first configure the policy. Here IPv4 let's call it policy R33 to R35 to color 20. This doesn't matter for layer 2 for EVPN traffic. It matters for layer 3 VPN traffic for auto steering. And by the way, I must have told this before, if you want to actually learn segment routing and not just see how it's implemented, make sure you check my course, and it's on this website here, ping-factory.com. So the metric type should still be DE, and let me just commit it like that and see that it uses the same path as before, because I haven't configured the disjoint option yet. So for segment routing traffic engineering policies, it shows the same path, the same seed list for both of these, 32 and 35. If I do a detail, this one is 24,025 and 22. So let's see, 22 and 25. So they use the exact same interfaces. This is the backup path, so this can be ignored. But let's also configure the disjointness and see how the path changes. So on the PCE, disjoint path, group ID1, actually it's group ID1, type node, this is what I want to avoid, same nodes, sub ID1. And here you configure the LSP's number that should be disjoint. Actually, you give it an ID and put the peer and the LSP name. So the first LSP is for this path computation client, which has this IPv4 address, and the LSP is this one. This is actually the policy, and these two should be disjoint. If you're a native, you should better understand what disjoint means. I've just heard the name, this word first when learning about disjoint paths in segment routing. So maybe it's easier for you to understand what I'm doing here if you know what disjoint path means. So let's now check again the policy, and it changed the label because it got re-optimized. Show segment routing traffic engineering policy detail. So we still have two policies. Number 2 uses this local label, number 1 uses this local label. And let's just see that first policy goes like that and the second one goes like that. So first policy takes this path and the second policy takes this path, even though, so you see here the interfaces. And this happens even though the second path has a much higher TE metric. So even if it's 101, which is much bigger than 2, it uses a different path because that's what we told it to do. And actually, let's now do the same for the second SR policy from 35 to 32, because right now we only have one here. So 33, 35, and 35, 5. By the way, you have this notepad also in the lab exam. So you can press Alt and replace more things at once. And this policy number 2. So from 35 to 33. Okay, and color 20. Okay. And this is done on the PCE. We do have two policies, and they're not disjoint because I should have configured a different group ID. So let's give it a try like this. What? 35, 35, 35. Bum, bum, bum. Let's see. There are some typos here, and we need to troubleshoot. I just issued the panic show run command, which is of course not helpful. So we should see the segment routing traffic engineering policies for peer IPv4 35, 35, 35, 1. Okay, color 10. Policy, okay, it's the wrong name here. And where to replace? I'll replace here the whole policy to have correct naming. No. Perfect. 35 to 33. So I just tell it like this. No PCE segment routing traffic engineering. And okay. And I do have different paths now. And let's review the policy. So first policy is for this destination for 33. Second is again for 33. By default, you would have computed the same path, but because I asked the SR-PCE to compute disjoint paths, the first one is with the TE metric of 2, and we know it. And the second one is with the TE metric of 101. And of course, you can see these. So this is the first one through gig 001, and this is the second one through gig 002. And I think that's mostly it. I don't know if I can show you. Actually, yeah, you can see if these restrictions are actually satisfied with this show PCE association command. You can see it's satisfied, and I removed this by mistake, but it doesn't matter too much. Now you've seen it work. Well, this is where you see the status satisfied. And by the way, you can also see the LSPs that are computed by the PCE. by the tunnel name, source destination, and also show PCE IPv4 path from source 33. So you can troubleshoot it. If you have a policy that's not going up, you can check if the SR-PCE knows a path from the source to the destination. And we're done with the disjoint part. And the last part is configuring an EVPN service and make it use one of these segment routing policies. And this will be in the next video.